So we'll now continue section 5.4, and we'll talk about properties and applications of logarithms. We're going to go back and review our properties very quickly and then look at some examples using those properties. So remember that we have a property that says if we have two things multiplied together, that we can break that up and use an addition in between the logs. We also have a property that says if we have two things that are divided, as in a fraction, we can break that up with a subtraction in between the logs. And our third property says that we can pull our exponents down to the front and simplify in that fashion. So we're going to look at an example that is asking us to use those properties. It says use the properties of logs to expand the following expressions as much as possible. That is to decompose the expressions into sums or differences of the simplest possible terms. So our first example is asking us to take log base 4 of 64 times x cubed times the square root of y. Now remember that property 1 deals with the product of terms. So in property 1 we have x times y and we break it up with a plus sign in between. So in this first example you want to note that the problem has three things that are multiplied together. It has 64 times x cubed times the square root of y. And so I'm going to use that first property to rewrite this as a sum of three logarithms. So we're going to have log base 4 of 64 plus log base 4 of x cubed plus log base 4 of the square root of y. And we're now going to take each of those separately and see what we can do to simplify. So the first one, notice that it does not have an x in it at all. So I'm going to come off to the side and I'm going to see if I can work this out. So remember that we want to set it equal to a variable. Now I don't want to use x or y because those are in our problem. So I think I'm going to use z here. Once we set it equal to something, we then want to put it in exponential form. So we'll take our base. We'll go to the other side to get our exponent and set it equal to the 64. So we have 4 to the z is equal to 64. Our goal here is to write both sides with the same base. So we realize that 64 can be written as 4 to the third because 4 times 4 times 4 is 64. So therefore, z is equal to 3. And so what we have done now is show that this first part is equal to 3. Okay, on the second part, the log base 4 of x cubed, remember that we have our third property, which says that if you have a power, that power can be pulled to the front of the log. So we can take this 3 and move it down to the front. So we can write this 3 log base 4 of x. And remember also that a square root can be written as a power. So the square root is the same thing as a 1/2 power. And so we can take that 1/2 power and pull it down to the front. So we'll have 1/2 log base 4 of y. And this is the final answer for this problem. This is all they're asking us to do, and not necessarily solve it, but to break it up and get it as simplified as possible using those properties. All right, so let's look at part B. Part B says log base a of the cubed root of x times y squared over z to the 4th. So again, remember that a cubed root can be written as a power, and we want to do that because we don't really have a property of logs that would apply for a radical. So let's go ahead and write this instead of the cubed root. Let's write it to the 1/3 power. So we have log base 3 of x y squared over z to the 4th, all raised to the 1/3 power. Now remember, your log property number 3 says you can take that 1/3 and move it to the front. So let's do that. So 1/3 log base 3 xy squared over z to the 4th. Now let's consider what is in parentheses. We have two things that are multiplied together on the top, and then we have a division for the z to the 4th. And so we're going to use a combination of the first two properties to expand out that parenthesis. So I'm going to write the 1/3, and then I'm going to put a bracket because the 1/3 is going to apply to everything that I'm about to do. And then I'm going to expand inside that parenthesis. So log base 3 of x plus log base 3 of y squared. That takes care of the multiplication on the top. Then remember, the fraction goes to a subtraction. So minus log base 3 of z to the 4th. Now, the only other thing that we can do is we can take those powers and move them to the front. So we have a squared power that can come down, and we have a 4th power that can come down. And so our final answer would look like 1/3 log base 3 of x plus 2 log base 3 of y minus 4 log base 3 of z. Okay, so, and as I'm looking at this, I see one small mistake that I made, and hopefully that's not confusing. I actually is a base 8, and so I just made a mistake there, made a base 3 out of it. So I would let me fix this real quick. This should be a base A, not a base 3 there. It doesn't change how we work the problem, but let's make it correct. All right, so it should have been a base A all the way down. Okay, all right, so there we go. Final answer is inside the box. Okay, so let's look at one more part of this. We have a problem that says log, and then it has 2.7 times 10 to the 4th divided by x to the negative 2. We have a note that says to be sure you remember that if you don't have a base that's explicitly written, that you are assuming that it is a base 10. And base 10 is typically used with scientific notation. So again, we've got this problem where on the top part you have two things that are multiplied together, and on the bottom part you have a division. And so we can use the first and second properties to expand this thing out, and I'm going to do that first. So I have log base 10 of 2.7, and we have plus, because it's a multiplication, log base 10 of 10 to the 4th. And then we have minus, because of the fraction, log base 10 of x to the negative 2. Now, let's see what we can do to get this thing simplified. So this one in the middle, I think I'm going to start here. Let's see if we can work that out. So I'm going to come off to the side somewhere, and let's set that equal to a variable. So let's see, we'll use y this time, and let's see if we can solve it. So we're going to take our base 10, go to the other side and get our exponent. So 10 to the y is equal to 10 to the 4th. And so if that's the case, then we can say, okay, so y has to equal 4, which means that this expression here has to equal 4. Now, this one, the log base 10 of 2.7, I know that I'm not going to be able to work that out with that decimal. So I'm either going to leave it alone, or I'm going to put it in my calculator in just a minute. Okay, and those are my two options. All right, and so on this one, I can take the negative 2 and pull it down to the front. And when I do, this negative and this subtraction is going to make a positive 2 log base 10 of x. Okay. And so our options at this point are to pretty much leave it like we've got right here. So this is an acceptable answer. Okay, or you could go in your calculator and you could type in log base 10 of 2.7. And then once you get an answer there, you could go ahead and add the 4 to that answer. And you would get 4.43 plus your 2 log base 10 of x. And this is also an acceptable answer. And it is appropriate for you to either evaluate that log or leave it in the exact form. It doesn't really make any difference, and you should just use the context of your problem to decide which one is going to be more convenient. Okay, so let's move on with our properties. This is a slightly different problem. It says use the properties of logs to condense the following expressions as much as possible. Rewrite the expressions as a sum or difference of as few logarithms as possible. So what this is telling us to do is to use our properties to sort of piece this back together. So look at this first problem where we have 2 times log base 3 of x over 3 minus log base 3 of 1 over y. And let's look specifically at this 2. This 2 used to be an exponent, but at some point it got pulled down to the front. So our first step is to take it back up. So let's take it back and make it an exponent. So we're going to write it log base 3 of x over 3 squared. All right, and I'm going to leave the rest of it alone for just a minute. So log base 3 of 1 over y. Now we see this subtraction on the inside here, so we know that we're going to have a fraction coming into play as we put this back together. Before I do that, however, I'm going to go ahead and distribute this squared inside this parenthesis on the first term, just making things a little bit easier. So x squared and 3 squared would be 9. That kind of gets that out of the way and helps me a little bit. Okay, so now let's take our 2 terms and let's put them together as a fraction. So it's going to look messy at first. We're going to have log base 3, and the top part of the fraction is going to be x squared over 9. And then we have a fraction bar, and then the bottom part of the fraction is going to be 1 over y. Now remember how we do this in terms of simplifying. We can't really divide fractions, so instead we multiply by a reciprocal. So this thing is going to look like log base 3. We're going to have x squared over 9, and we're going to be multiplying by y over 1. So we have log base 3 of x squared times y over 9. And this is our condensed version of that problem. All right, so our next one, natural log of x squared minus 1/2 natural log of y plus the natural log of 2. Now again, we see this 1/2 in the front. We know that at some point it got brought down. So our first step is to take it back up. So I'm going to make it natural log of y to the 1/2 power, and I'm going to leave everything else alone. Now these first 2, I see a subtraction in between, so I know that that's going to be a fraction. So let's go ahead with that, and let's write this as a fraction. So we're going to have natural log of x squared over y to the 1/2, and we'll come back and sort of clean that up in just a minute if we need to. And then we have plus the natural log of 2. So now combining these 2, we have this plus in between, which we know goes back to being multiplication. So let's put these 2 together as a multiplication problem. So the natural log of 2 times this fraction is going to give me 2x squared over y to the 1/2. And I can leave it like that, or you do have the option of taking that y to the 1/2 and writing it as a square root. All right, and our last one says log base b of 5 plus 2 log base b of x to the negative 1. Again, here's a power that got brought down. So our first step is to take that number in the front, that 2, and move it up. So when you move that 2 up, 2 times negative 1 is going to make a negative 2. Now you see that you have a plus in between your logs, which you know makes multiplication. So we'll put those two together as one log, making it 5 times x to the negative 2. That's a correct answer. You also could write it log base b of 5 over x squared if you would prefer not to have the negative exponent. Either way is appropriate there.